Hello everyone. I hope everyone is doing well, everyone is safe. So welcome to this tutorial video where I'm going to show you how we can create data loaders for different scenarios of data augmentations in PyTorch. So basically we can use data augmentation to have augmented images to reduce overfitting. We can also use it to increase the dataset size or also to create some balance in the dataset. So let's see the different scenarios of data augmentation. So the first scenario is basically a simple augmentation. So we can have one input image and we apply some kind of augmentation, say random crop, and we have one augmented image. So one input and one output. And we can apply any kind of augmentation. Say we can also apply random rotation, but again here it's one input and one output. Or we can even apply a series of augmentations, a random crop followed by a random rotation, and then we get a augmented image. Now here as well we have one input and one output. So this could be the scenario one, where we just want an augmented image for our training. Another scenario could be that we have less amount of data set and we want to use augmentation to increase the data set size. So say for example, you have one input image and we apply one augmentation and we have one augmented image. Then for the same input image, we apply some other kind of augmentation, say random rotation, and then we have another augmented image. And then we apply some random perspective transformation and we have another augmented image. So with just one input image, we are able to create three augmented images, which will increase our dataset size and we can use for training. And then the third scenario is augmenting the selective classes. So say uh, we have imbalance in the dataset, cats and dogs. So cats, we have sufficient samples, but sorry, dogs, we have sufficient samples and cats, we have less samples. So in the dogs, we can just have a simple transformation, the first one where we have one input, one output. And in case of the cats, we can increase the size, the dataset size for the cat class by having multiple augmented image from a single input. So here we have like one input and sorry, this should be three output, and then basically we have two input and output. So I hope you got the idea of three different scenarios. And in PyTorch or any data loader, you know that when we create this data loader, we have some data generator which loads the data. And here we can have two kinds of data generator. So one is that you have the images, and then during initialization of your data generator, you read all the images into an array, and basically that's it. If you have enough space in memory, then you can read all the images and store in memory. And when you create the data loader and when you're training and fetching the data, then it will simply return the data at the requested index, say directly the array. Another scenario could be the where you don't have enough memory to load all the red images, you know, in the memory. So what you do, instead of reading beforehand, you just read the file names, their locations, and then when we want to train it and when we ask the data loader to return the data, then it will get the image name at the index, then it will read it like on the go, and then it will return the array. So you can understand these two scenarios of data loader, where one we can load all the image arrays. We can read and load it, in the memory and just fetch it when we need it. And here, when we don't have enough memory to store all the tensors, then we can just store the image names. And then when we are reading it, when we're asking the data loader to return it, we can get the image names, and then we can read it on the go and get the array and then give it for training. So for this, like the first video, we will code out the scenario one of data augmentation. We'll see how we can create this augmented image and how we can create data loaders with this data. And we'll do it for all the both the types of data generators, where where in one case we are reading the images beforehand, and in another case we are reading the images on the go. So with that, let's get started with the first scenario. So we are going to do the augmentation using a PyTorch module called transform, which is imported from the Torch Vision module. So let's see how we can use this transform module to do different kind of data augmentation. So let's first see how to do the data augmentation. So you just need to import the transform from the Torch Vision, and to read the images, I am using the PI library. So let's run this, and I have one image of a cat. So I'll just simply open this image and let's see. And here is the augmentation or the transformation that I'm defining. So I am just directly using the random perspective transform from the transforms module, and I'm giving the parameter how to do this random perspective, how much of distortion, and then I am having this random rotation. I'm giving the degree, and then random affine transformation, and then random crop. And then we can also define this compose of transformation where we can do series of augmentation. For example, this transform.compose, and we define random crop followed by the random rotation. And then in order to do the augmentation, you simply have to pass the image through the define transform function, and you will get an augmented image. Okay, so let's run this. So this is the first augmented image, which is the random perspective, and you can see the original image and how it got augmented. Then similarly, we can have this random rotation image. It got rotated by some 1995 degree, and then we can have this random affine transformation, scaling, rotation, and in a combination. And then we can have this crop, randomly getting cropped. And then we can have this compose where we did the crop followed by the rotation. So you can see it. So this is how you can apply augmentation using the PyTorch transforms function, sorry. So now let's look at the data loader. Okay. So data loader is really important for any of the model that you will be training, because what it does, it's a very important function that takes in the raw data and convert in a data that can be consumed by the model for training. Okay, so that's the role of the data loader. So let's first see an example of a simple data loader format in PyTorch. So in PyTorch, there is a dataset module that helps you create this data generator function. So it has three function. One is this init function, then the length function, and the get item function. So in the init function, basically, you will define your entire data set in this XY pair in any desired format that you want. But let's say this is a classification example. And here in the init function, you will define the XY pair. Okay. And in the get item function, basically, it will you will be fetching these items of XY pair one by one. So this will yield the item one by one. Now in the init phase, when we're defining the XY pair, we can define in two ways, as we discussed in few slides ago. One is that we can, if you don't have, enough memory to store it in the RAM, you define the image ID or image location and label pair. So image name 1, label 1, image name 2, label 2. So you define this way. And in the get item phase, you fetch this image, read the image, apply any transformation that you want to do, and return the image and label. And in the second way is that in the init function itself, you read all the data, and you store in the RAM the data and label pair. Okay, and then in the get item phase, you simply return the data and the label. Okay, so that's it. So this is the role of the data generator function, and I showed you in two ways. Anyways, in both the ways, once we have the data generator which returns one sample at a time, so this will return one sample at a time. Now we can define a data loader using this data generator function that we just saw. And Torch has a module for data loader called the data loader. And so what it does is basically it will take this data generator uh, module. I mean, this is a class, so you just create an object of this data generator, and then it will take other parameters like batch size, whether you want to shuffle or you want to drop the last batch, and then it will yield batches of data. So this will give you one by one, and using data loader you can get the batches of the data. Okay, so basically we use this data loader to get the batch of data, and this is then feed into the network for the training. Now for your information, the function that is used in this data loader to prepare this batch of data is the default collate function. Okay, So using this function, what it does is it will fetch the data from the data generator one by one, and then it will stack it in a batch and then return it to you as a batch of data. Now I'm showing this here because later we will see how we can write this custom collate function to create data loader uh, data loader where we can do stacking in a different way rather than directly stacking item one by one. So we can get creative, and maybe in the second video or third video we'll see how we can create the default custom collate function for another for different augmentation scenario. With that introduction, let's get started with writing the data loader. Okay, and first, so I have this notebook prepared. So let me escape here. Let's go to the notebook. So this is the data loader scenario one, of the augmentation, and data generator type one. So type one means when we have read the image in the init function itself, and type two will be when we have just read the image names and not the actual image. Both will not make much difference in this scenario. So let's see how we can do that. Also, if you want to create a data loader for different kind of inputs, I already have a video on my channel. You can check it out. Okay, so for this video, I'll be using the dataset of, the dogs versus cat from the Kaggle. So I have already downloaded it. So there are around 12,500 cats and 12,500 dogs images. And also, yeah, for this data augmentation, actually, you can also refer here. There are different, I'll put the link. There are different kind of transformations that you can, do with the PyTorch. But coming back to the first scenario of data loader, so there are a lot of images, but I have prepared the CSV file of image and label. So, and I have just created a mini train labels mini.csv with 200 samples from each cat and dog classes for this demo. And also the script to prepare the annotation file is here. So basically just reading the file and creating this image name and, uh, labels column. So we'll not discuss this. This will also be shared with you. Let's go to the data loader part. So what we are going to do is first import all the necessary modules, the data set function or the data set class, which will help us to create data generator, and then the data loader module and the transform to do the transformation. So let me run this, and this is a helper function to visualize the images, and this is our main this data generator function that I was talking about. So here what we'll have, we'll have this class called dataset loader, which is inheriting from this dataset module of PyTorch, and I'll have the init function, the length function, and get item function. But also I have a helper function called load data to prepare this XY label pairs. Okay, so here basically giving the root path means the path where my data and uh, the images, the annotation file is stored, the data directory, the annotation file, the data type. So this all you can modify it, but yeah, just let's go through it. So here I am defining the path of the data, and then the label path means the annotation file which is here. Okay, and then the transformation which will be passing to it. And then once I have passed it, I'll call this helper function called self.loadData. And what it does is basically it will read the CSV file, and then it will create pair of this XY pair. So it will read the data because this is of the type 1. So let's see. So we have this list, empty list. So I'm going to loop over all these samples, and I'm going to read this image name and its corresponding label. Okay, so I have read the label and the image name, and that this image I'll open it with the PI library, and I'll apply any transformation or augmentation that I want to apply, and I'll simply append this image label pair to here. Okay, so this is where we have defined our collection of XY pair. Now, once this is done, then basically when we call this dataset loader function, it will by default call this get item, which will simply get us one by one this image label pair and return it to us. Okay, so this is your data generator class that we have defined. Now let's define the parameters. So for me, this is the root path, the data directory, and the annotation file. And let's first see the scenario when we don't have any augmentation. So basically, uh, although I'm applying a transformation, but it's not an augmentation. It's basically doing a resize because my image size are a varying size. I just want to bring some coherency here just for sake of demo. And then I convert in a tensor. And then this is the transform train. So when we apply augmentation, we don't need to apply on validation or test dataset. Mostly we do on the train dataset. So we can have two different transformation for training as well as testing. But here both is same because we don't have any augmentation. Now I will create a data generator object by the defined class above, and I'll pass the parameters. And then I have this data generator function. And as I told you, I have 200 cats and 200 dogs images. Let's see the number of samples we have, which is 400, obviously. Now let's grab one of the sample directly by indexing. So I will have this image label pair, and let's take number 10, and then I will pass it to the visualize helper function that we created, and let's see. So we can see this is the image and its label is 0. So cats I have labeled as 0 and dogs as 1. Now once we have this training data generator, we can use this to create the data loader. So in the data loader module, we simply pass this dataset object that we have created from this data generator class that we defined earlier, and then I give the batch size and whether I want to shuffle it or not. So I simply create it, and now we can fetch instead of here when we were having this simple uh, data generator function, it was getting image one by one. Here we can have the batch of data. Okay, so we will see. Let's visualize one batch of data. So in this one batch of data, you will see there were 12 samples, and we have the images as well as their labels. So this is cat 0, dog 1, dog 1, dog 1, cat 0, and we have 12 images. Okay, I can show you this shape also of the batch. So basically data dot shape, and it says 12 or 3.128 by 128. Okay, great. Now let's see when we apply a single transformation. So the transformation which I'm choosing is random perspective transformation. And in the training, I am applying this transformation. After resizing, I'm applying it. And for testing, say I am not applying any transformation. So here then again, I will create my data generator object using this dataset loader class that we defined. We'll give the root path data directory same, just the transformation will change. And let's see. And the length of dataset should be 400. This is some warning. Let's ignore for now. And now suppose we choose one sample. So the augmentation is already applied to it. So you can see the same image when we were choosing one sample without augmentation. This was it. And now we have applied the augmentation as we defined in our class. And we have our augmentation of random perspective. Now this we can use this define dataset function to create the data loader. Again, same thing. And now when we visualize this batch of data of 12 samples, so here we were having, all raw images, and here we have the augmented batch of augmented images. Then we can also do a compose where we can apply series of transformation, the scenarios that I was talking about, if you remember from here. So, one, or we can apply series of transformation for okay, like random crop. So here I have defined the random perspective and random crop two transformations. Okay, so let me just run this, and let's run this. So this will simply just give the same thing, just that now two augmentation would be applied, cropped and perspective transformation. And same thing again, we can use this to create our data loader. And when we fetch our data loader, we'll get a batch of augmented 12 images. Yes. So that's it. This is a very, and you can then now use this data loader function for training. And this is the scenario one for data generator type 1. And by type 1, I mean yeah, when we pre-read the images. Now let's see for the second type where we don't read the images from before. We just have the image names and we read the images on the go. So let's see this example. data generator type 2. So everything is pretty much the same. So I have the same function of visualize. Now let's see the changes that we have done here. Now in the previous scenario, when we were in this helper load data function, we were reading the images here itself. So let me go back and show it to you. So when we were loading the data during the init function itself, we were opening the image, reading it, applying the transformation, and then creating this image label pair. Here, what we are doing in the load is we are reading the image name, we are reading the labels, but we are not reading the image. We are simply creating the pair of image name and label. Okay, this will be used in the case when we have huge amount of data set and you don't have memory to store the read data. And in the get item phase, when we are getting the item, so we were getting this one pair of image name and label, and then at there, when we are asking for it, there we are opening the image, we are applying the transformation, and then we are returning the image and label pair. So that's the only difference, and remaining everything is same. So I hope you get it. And this is basically my paths, and this is the scenario when we apply no augmentation. So you'll see there is no difference. So we have 400 samples, and if I read this, and then I can use this created data generator object to initialize my data loader object, and then I can fetch from this data loader, and then I can visualize the pair of, not pair, this 12 set, a batch of 12 images. Okay, the dog is 1, the cat is 0, and then applying single transformation. So it's basically the same thing. There is no changes, and you will see applying a single augmentation and the same thing for data loader batch of 12, and then applying the compose where I did previously, applying random perspective and random crop, and then so I'm resizing it to 128 by 128 initially because the images are of various size, could some are small, big, so just to get a uniformity, and then apply my augmentation, and then basically same thing. And yep, so you can see the size is 12, and yep, so that's it. I think you got the idea of how you can create this data loader for the first scenario where we are simply doing simple, straightforward, putting one input image and getting one augmented output, and how we can use this to create the data loader. And we saw it that we are doing it for both the scenarios of the data loader where we can read the image or we read the image name. Either we read the image first or we read the image name first. So I hope you got some understanding, you got the idea, and I'll share the code, I'll share the notebook, everything. And in the next video, we will then cover the second scenario where we'll use augmentation to to increase the size of the data set. So basically one input and multiple augmented images, and then we can create the data loader using this for both the scenarios as we discussed. So I hope you learned something. I hope this helps. And till then, keep learning and keep exploring neurons. Be safe. Take care. Bye bye.